This is lesson 5. In this lesson we will cover quadratic equations. So what exactly is a quadratic equation? A quadratic equation is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. Notice we have a root here of x squared as well as an x without a root. Well, basically it just has a root of 1. So how would we go about solving this quadratic equation? There are several methods we can use. Let's start by looking at basic factoring. So let's start with x squared plus 5x plus 6 equals 0. We want to solve this. Well, in order to solve this, one method we can use is factoring. We need to find two numbers which multiplied together give you 6 and when added together give you 5. Now notice we've got two plus signs here, so we're going to have plus signs in our factors. So we know in order to get x squared, we're going to have x times x. We'll do it as x squared. Now, as I said, the signs are going to be positive because both of these signs are positive. The plus in front of the 6 indicates that both numbers are going to have the same sign. The plus in front of the 5 says that both of those signs have to be positive. So again, what two numbers, when multiplied together, give you 6, and when added together, give you 5? And obviously the answers are 3 and 2. So x squared plus 5x plus 6 equals 0 when factored is simply x plus 3 times x plus 2. Now, what is x equal to? Well, x could be one of two values. We set each of these factors equal to 0. We then solve each of these expressions for x. And our final result for this becomes x equals minus 3, or x could equal minus 2. So this is the solution for this particular quadratic equation. Now let's look at a different example. We now have x squared minus 5x plus 6 equals 0. It looks very similar to the previous example, but notice now we have a minus in front of the 5. We still have a plus in front of the 6, which indicates that we have both signs the same, but the minus in front of this 5 now tells us that both signs are now negative. So now we have an x and an x, but now instead of having two positive signs, we have two negative signs. Now, again, we're going to look for the two numbers whose product is 6 and whose sum is 5. And obviously, our numbers again are 3 and 2, so now we have x minus 3 times x minus 2 equals 0. Well, to solve for x, again, we set each of these equal to 0 and solve for x. So we'll get two solutions. And our result now is x equals positive 3 and x equals positive 2. So now let's look at x squared plus 5x minus 6 equals 0. Again, very similar to the previous two examples, but now we've got a minus in front of the 6 and a plus in front of the 5. Well, we're still going to start off with what we had before. So we're still going to have an x times an x, which will give us x squared. But what happens to the signs? We now have a minus in front of the 6 and a plus in front of the 5. Well, the minus in front of the 6 tells us that we have one plus and one minus sign. Now, obviously, we still need two numbers whose product is 6. So we could have 2 times 3, but we could also have 6 times 1. But now, since the signs are different, we're looking for two numbers whose product is 6 and whose difference is 5. Well, obviously, then we're going to go with 6 and 1. But where does the 6 go? Where does the 1 go? All right, look, we have a positive sign in front of the 5. That means the larger number, or larger absolute value number, goes with the positive sign. So the 6 is going to go with the positive sign, and the 1 is going to go with the negative sign. So now we have x plus 6 times x minus 1 equals 0. Again, we set each of these factors equal to 0 and solve for x. So our result then is x is equal to minus 6 and x is equal to plus 1. We have one last example to consider. So what if I have x squared minus 5x minus 6 equals 0? Notice both signs are negative. We still have our x and our x, and we have different signs, again, because we have the minus in front of the 6. Now, obviously, we're going to look for two numbers who multiply together is equal to 6 and whose difference is 5, and we're still going to get 6 and 1. But where does the 6 go? Where does the 1 go? Notice we have a negative sign in front of the 5. The larger number, which is the 6, is going to go with the negative sign. The smaller number, which is the 1, will go with the positive sign. So again, we're going to set each of these factors equal to 0 and solve for x. So now our result comes out x equals positive 6 and x equals negative 1. So here are the four cases of basic factoring. So now let's talk about another method for solving quadratics, and that is completing the square. So let's start by looking at an example. Say I've got x squared minus 6x minus 3 equals 0. Well, if I try and factor this, the only factors for 3 are 3 and 1, and neither the sum or the difference of 3 and 1 is equal to 6. So I can't really factor this. Well, let's look at completing the square. The first thing I'm going to do is move the 3 over to the right side. So if I add 3 to both sides, I end up with x squared minus 6x on the left side of the equal sign and plus 3 on the right side of the equal sign. All right, now the next step is I am going to take and look at this coefficient right here, the 6. I'm going to take half of 6, which is minus 3, and square it, which gives me plus 9. But if I add the plus 9 to the left of the equal sign, I must also do it to the right to keep things equal. Well, now if I look to try and factor the left side of the equal sign, I notice that I've got a plus 9. So that tells me both my signs are going to be the same. And then I look in the middle term, I've got a minus 6. So that means both signs are going to be negative. So now I look, what are the factors for 9 whose sum is equal to 6? Well, it's obviously 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. So now I have x minus 3 times x minus 3 is equal to 12. Well, I could rewrite this as simply x minus 3 squared is equal to 12. Well, I can't set x minus 3 equal to 12, but if I take the square root of both sides, look what happens. And we now have x minus 3 is equal to plus or minus the square root of 12. Well, as you know, we can take and simplify that square root of 12, so our final answer would become x is equal to 3 plus or minus 2 times the square root of 3. So here's an example of how we can solve a quadratic by simply completing the square, okay? We probably don't want to use this if we can factor it, but if we can't factor it, then we can certainly use completing the square. Now the last method that we're going to talk about to solve a quadratic equation is the quadratic formula. Now, the beauty of the quadratic formula, it will always work. So whether it's factorable, whether you want to complete the square, whatever you want to do, the quadratic formula always works. So let's start by remembering what the general form is of the quadratic equation. If we've got something that looks like this, ax squared plus bx plus c equals 0, then the quadratic formula for this would become, x, in this case, would be equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So now let's look at an example. So let's say we've got 3x squared plus x minus 1 equals 0, and we're asked to solve this quadratic. Well, doesn't look too promising in terms of factoring it. I suppose I could try and complete the square, but that looks a little cumbersome as well. So instead, what I'm going to do is use the quadratic formula. Now note, in this particular example, a is equal to 3, b is equal to positive 1, and c is equal to negative 1. Well, now let's plug these values for a, b, and c into the quadratic formula and see what we get. So this becomes x is equal to minus 1 plus or minus the square root of 1 squared minus 4 times 3 times minus 1 all over 2 times 3. Now if we simplify this, we should get our answer. So our final answer, therefore, is x is equal to minus 1 plus or minus the square root of 13 over 6. Again, notice we have two answers, since this is a quadratic. Minus 1 plus the square root of 13 over 6, and minus 1 minus the square root of 13 over 6. Now this completes this particular lesson, so move on right now to the worksheet.